let's look at the solution for this one. Here we've got another piston cylinder assembly. We have two processes, A and B, and we're going between the same end states, which will be 1 and 2. Our pressure is 10 bar at state 1. Here's our volume. State 1 is 0.1. We have our internal energy, which is 400 kilojoules, and then we've got the values at state 2. So we got 1, 1, and then 200. Process A, we know that going between 1 and 2, we've got this PV equals constant relationship. And then for process B, this one has a kind of a two-step thing going on here. We've got a constant volume process. That's important to pay attention to. From state 1 to a pressure of 2 bar. And then after it reaches 2 bar, it's got a linear pressure volume process to state 2. We're going to ignore the kinetic and potential effects, and then for each of these processes we're going to sketch the process on our PV coordinates, and we'll look at work and the heat transfer. Okay, so let's first do part A, and we'll draw this out on the diagram. So here's V, here's P, that's cubic meters, and then this is bar. Let's do process A first. We know our states at 1 here. At state 1, we've got this pressure, this volume, this internal energy. So on here, we've got a pressure of 10, a volume of 0.1. So let's just put 0.1, and then our pressure is up here at 10. So there's state 1. Now at state 2, our pressure drops to 1 bar and the volume increases to 1. So let's put those numbers on here, like that, and then we've got that. Alright, so now we've got that relationship there, and then let's just connect these two like that. So this is process A. Now process B is, like we said, kind of a two-step thing going on. So we're going to have to drop to a pressure of 2 bar. Alright, and then we're going to have this linear pressure volume process. So let's put a 2 here. So we're going to drop to this. Notice it was constant volume, so it's just straight down. And then after we get to this pressure, we have this linear pressure volume process to state 2. So essentially what you need to do is just draw a linear curve there, so just a straight line connecting this point to this point, and this whole thing together is B. Two different processes going between 1 and 2. They just get there different ways, that's all. Now we want to look at work and heat transfer. Let's look at process A first. For process A, when we look at work, you can use your integral equation. So that's going to be going from our initial volume, which is 0.1, to the final volume, which is 1.0. And then we have to have P in here, the pressure equation. So we know PV equals constant. So for this one, you're going to solve this for P. And just like we've seen in the past, P is going to be C over V. So plug that in like that. Now when you integrate that, remember C is a constant, it pulls out, you're going to have C times the natural log of V. And you're going to evaluate at these two values. The value for the constant here you can find by either using state 1 or state 2. I'll just go ahead and use state 1. We can put that C is equal to P1 V1. And then here when you do the natural log, you're going to get the volume 2 over volume 1, like that. So now we have this. Now let's go ahead and plug in our numbers. P1 was 10 bar. V1 was 0.1, that's cubic meters. Now we have this natural log in here. Units there go away. You have that. Now we still don't have the right units. We want kilojoules. So again, you got to use those same conversions we've been looking at. So the 10 to the 5th, oops, this is squared here. 10 to the 5th Newton per meter squared over 1 bar. That gets rid of the bar. And then from there, we want to get to kilojoules. So you have 1 kilojoule per 10 to the 3rd Newton meter. And then what that gives you is a work for process A of 230.26 kilojoules. This is a positive number, so work was done by the system. Now when we want to find Q, you're going to go to your energy balance equation. Basically, anytime you want to find Q, that's the equation you're going to go to is energy balance. Let's write that out. We're going to have delta U plus delta KE plus delta PE. It's going to equal QA minus WA. These two go away because it told us to ignore them. And we were given the U values in the problem. Essentially now all we need to do is plug in the values and solve for Q. We're going to have 200 minus 400 for the delta U, and then put plus 230.26 kilojoules. That's going to equal QA. Go through and do the calculations. You get QA is 30.26 kilojoules. Now this is positive, so there's energy due to heat coming into the system. Now let's do the same thing for process B. Now this one, process B, this first part here was constant volume. There's no work done on this one right here. Now this one does have a volume change. All right, so for this one, what we're going to do, since this just says a linear relationship, we're just going to kind of take the average for our pressure and do it that way. So our work for B, let's just say, is the average pressure between these 2 points, since we don't know the exact relationship. And then we're going to multiply that by the change in volume. All right, so we'll have V2 minus V1. Now our average pressure, we're going between 2 and 1. So we'll have 2 plus 1 and then put that over 2. And then for the volumes here, we're going between 1 and 0.1. And these are cubic meter, that's a 3 there. Once again, we're stuck with this bar cubic meters for the units, so you got to convert. So you get 10 to the 5th Newton per meter squared per 1 bar, and then multiply that by 1 kilojoule per 10 to the 3rd Newton meters. All right, and so then that will give you your conversions that you need, so you can go through and solve. So the work for process B is going to be 135 kilojoules. This is positive, so work was done on, or actually work was done by the system. All right, so if it's positive, it's done by the system. Now we need to find QB. You're going to go to your energy balance equation for that one. So let's write that out. So delta U plus delta KE plus delta PE is going to equal QB minus WB. Now these go away. And then just solve for QB because we know this other information. For QB, we're going to have 200 minus 400. That's kilojoules. And then we have plus 135 kilojoules. That gives us negative 65 kilojoules. And that's our Q for process B. This negative sign here means we're going to be losing heat energy in this process.